Japan.
Thank you, Chairperson. Good morning, everyone. I'm Yoshio Kiku, National Institute of Animal Health, NARO. I live in Sapporo. Welcome to Sapporo. You know, Sapporo is one of the famous sightseeing places in Japan. Have you eaten some Sapporo local food yet? Okay. Today, I'm introduced to talk about the cytokine therapy for bovine mastitis. This slide shows the percentage of injuries and diseases in Japanese dairy cattle. Here area is a disease of the teeth and others, almost 30%. Over the years, 30% of dairy cattle diseases are mastitis. You know, during lactation, clinical mastitis is usually treated by intramammary infusions of antibiotics. On the other hand, during dry period, blanket dry cow therapy is still used to improve other health on dairy farms now. Mastitis control is mainly the use of antibiotics. However, excessive or inappropriate use can lead to the emergence of resistant bacteria which do not respond to antibiotic treatment. This slide shows the antimicrobial resistance. Antimicrobial resistance, AMR, is a major threat to human and animal health. Therefore, the development of alternative therapies to antibiotics is urgently required from a food safety standpoint. At the Iseshima Summit 2016, world leaders in the G7 have declared AMR to be a global crisis. Today, I'd like to introduce an aggressive measure which alternative to antibiotics therapy for bovine mastitis. It is cytokine therapy. Now, we have two treatment strategies for bovine mastitis. We can use non-antibiotics and antibiotics. And then I like to add the new technologies as a biopharmaceuticals, it's cytokine. I think that this strategy has 4 possibilities. For vets, they can have more choices for the treatment. And for farmers, they can improve milk productivity. And for consumers, they can get the more high-quality milk. The last, for public health, we can lead to measures against AMR. At first, I'd like to talk about previous experiment like this. We evaluated the effect of 3 cytokines, G-CSF, IL-8, and GM-CSF. As a mastitis treatment test, we challenged the single dose or combined with GM-CSF, combined with antibiotics. Please look at this figure. This figure shows the single dose challenges of GM-CSF and IL-8. After the treatment test, the day 14, we can confirm the therapeutic effect. about 14% the cows shows the efficacy of cytokine therapy. However, these products produced by the baculovirus insect cell expression system are generally very expensive. Today's background and objective. The recombinant bovine GM-CSF produced by the baculovirus insect cell expression system has about 40% therapeutic effect for SA mastitis. But it's difficult to produce the GM-CSF for low price by this expression system. But we developed a system for stable germline transformation in the silkworm Bombyx mori in 2000, and the mass production method of such a useful protein, for example, GM-CSF. The present study was designed to investigate the effect of the intramammary infusion of GM-CSF produced in transgenic silkworm or milk SCC in other affected with subclinical mastitis. Material and method. Animals. We use 18 lactating cattle. They have a naturally SA infected subclinical mastitis whose milk SCC had been exceeding the level of 1 million cells per milliliter, was selected as a member of the GM-CSF group and the control group. Cytokines. GM-CSF, TZ GM-CSF was produced in transgenic silkworm, like this. At the GM-CSF group, the intramammary infusion of TZ GM-CSF 400 microgram per quarter was conducted immediately after the morning milking on day 0. As the control group, 5 milliliters of saline was also infused into the system. Sampling. Blood and milk samples were collected prior to the treatment, and 0.25, 1, 2, 3, 7, and 14 days post-infusion of TZGM-CSF was saline. Analysis. Chemiluminescence activity, mononuclear cell populations, SCC, and the bacterial count in milk were measured in order to evaluate the therapeutic effect of TZGM-CSF. Criteria of mastitis in the cattle was determined using the measurement of SCC, using the Diraber machine. Result. The SCC and CMT score had a transient rise on day 0.25 after the infusion of TZGM-CSF, and were followed by the smooth and significant decline on day 3, day 7, and day 14. At the end of the experiment, SCC of cows infused with TZGM-CSF was lower compared with day 0. 7 of 9 cows in the GM-CSF group showed a decreased SCC on day 14 compared to day 0. The SA count in the GM-CSF group were lower than the control group at day 7. Day 7. In the other hand, in the GM-CS group, the CL activity in milk tended to be higher on day 0.25 after the infusion of solution and was significantly lower on day 14. This figure shows the intramammary infusion of TZGM-CSF was implicated in neutrophic phagocytosis. The percentage of CD4 positive helper T cell and CD4 positive CD45 RO positive cells memory T cell increased on day 1, 2, 3, 7, and 14 post-infusion of GM-CSF. This means the intramammary infusion of GM-CSF was implicated in alteration of the population of mononuclear cells in milk. Conclusions. The present study investigates the effect of GM-CSF on the immune response on the mammary gland to infection by mastitis causing SA. Our study indicated that the infusion of GM-CSF accelerates the bactericidal activity of neutrophils and the memory function of helper T cells in the mammary gland infected with mastitis, and these cells induce the enhancement of innate immunity in the mammary gland. These results suggested that the intramammary infusion of GM-CSF produced in transgenic silkworm has a high potential as a therapeutic agent for mastitis of dairy cows. Thank you for attention. Enjoy your study.